Welcome back to another video. In this video, we'll be talking about math games as well as a card trick. So, what exactly is a math game? Well, this term is very vague, so let's go over what it could mean. It could be a game in which the rules, strategies, and outcomes are determined by mathematical factors, such as in tic-tac-toe, or it could be a game in which could test the player's mathematics skills, reasoning, or understanding of mathematical concepts, such as in games like Kakuro, where you need to add up numbers such that their sum in the row or column equals to the specified number. Or it can just be a puzzle game that challenges the player's spatial reasoning skills. So, what are some types and examples of a math game? So, we have two main types of games, combinatorial and non-combinatorial games. In combinatorial games, there is absolutely no luck involved, and each player knows everything about the current state of the game. While in non-combinatorial games, randomness is involved, and each player is unsure of the full current state of the game. Since math games are usually not dependent on luck, they are thus combinatorial in nature. As for examples of math games, combinatorial games, including board games, are considered math games. Such examples include chess and Go, as well as tic-tac-toe. Puzzle games, including tanagrams, are also considered math games, while card tricks and card games, including the 27 card trick which will be shown to you later on, will also be considered under math games. Of course, there are other math games that I have not listed here, and these are just some examples. Now I will be having someone else explain the 27 card trick.
Hi, I'm Shihong, and today I'll be demonstrating the 27 card trick. We have a deck here, but shockingly, we only need 27 cards. Right here, we have the ace through 9 of 3 suits, but it's ordered, so let's shuffle them up. Now, we'll pick a random card. 6 of spades. And we'll distribute the cards equally into 3 piles, and take note of where our chosen card lands. We'll take the deck with our card and put it in between the other two, and repeat this whole process 2 more times. One last time. And now, I'm feeling lucky today, so I'll try and guess where the card is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it? It might be this one. But 13 is a bit unlucky, so let's do 14 instead. Wow, it's the 6 of spades. Who would have thought? Is this magic? Well, no, it's math. And now I'll let Woonhan tell you how it's done.
So do you wonder why the middle card is the chosen card? I'll explain the trick for you. This trick works based on modular arithmetic. Let's suppose that the card is this card, 22, as indicated here. When we split the cards like this, we actually see that the card 22, chosen by the volunteer, is in the left pile, and the pile is chosen by the volunteer. So we know that one of these 9 blue cards must be the volunteer's card. So we put this in the middle and we resplit it again. What we notice is that now we can definitely deduce that none of the bottom or top 3 cards is the volunteer's card. Rather, it has to be one of the 3 middle ones. So the volunteer does this again. The volunteer chooses the middle pile because that contains card 22. And we know that one of these green cards must contain the volunteer's cards. So we do the same thing again. We put it in the middle and then we redistribute it. Now we can clearly see how it's a middle card. Across all the 3 piles, the green cards, the ones that we know must be one of them must contain the volunteer's cards, are all in the middle. So whenever the volunteer chooses the 3rd pile this time for this 22nd card, which is the one that they chose, all we have to do is take that pile, we take the middle card, and that is our card.
Now, let's look at some other math games. In 2048, you swipe pieces in different directions, and the number 2 to the end can merge with another copy of itself to form the next power of 2. The ultimate goal is to reach the 2048 tile, and you can continue playing to reach higher powers of 2 if you want. There is some luck involved, with a 1 in 10 chance of a 4 spawning, but it is still largely strategy based. Sprouts is a 2-player game. In each person's move, they can make a curve between 2 dots and mark a dot on it. No dot can have more than 3 curves passing through it, and curves cannot cross. The player who makes the last move wins. In the game of 24, we want to form the number 24 from 4 numbers. The only allowed operations are addition, subtraction, multiplication, division, and parentheses. Usually this is played with cards, with A denoting 1, J denoting 11, Q denoting 12, and K denoting 13. A possible solution for this set of 4 cards is as follows. 4 times 5 plus 2 minus 1, which gives 4 times 6, or 24. And finally, we have some other board games. These are some 2-player board games such as chess, checkers, Go, and Othello. They have quite deep strategy, and they are more popular and competitive, but these are more of combinatorial games than math games. With this, we have come to the end of the video. Enjoy mathing and gaming!